it says draw all the possible isomers and write the IUPAC names. And all I could find were, let me see that. Still can't see. Okay, that's a little better.
Could we get the front light or? Could we get the front light maybe?
It'll blind it out.
Let's try one more set of lights. That's about all we can see. I guess I wrote too late. Anyhow, there's an optical isomer possible, and there's 1, 2, 3, 4, 5 hydrogens, 1 chlorine, 1 oxygen. One of the things you can look at it looks like it could be an alcohol, which is the way I did it. And so that's 1 chloroethanol. And this is an optical, so both structures are different, drawing it like that with the aeroplane. And we didn't worry about how to name it, showing the different isomers. Somebody guessed plus or minus, I'm not going to mark that wrong, but that's the only name we need for that. If I put the chlorine over here, 2 chloroethanol, we can make an ether out of it. No matter where we put the chloro, it's still chloromethoxymethane.
Is that why you don't number it?
Right, because there's only one place.
Okay.
If we put the chlorine over here, it's still chloromethoxymethane. I guess you could say methoxychloromethane. I will accept that also. But that's about all I will do for that. And then the last one, I accepted any of 3 names, or I will accept any of 3 names because we didn't cover the nomenclature of this. But this is putting the CL over here. And these are all the ones you can draw, by the way. So this is either ethyl, hypo, H-Y-P-O, that's what that says. Hypochlorite, in other words, ClO minus is the chlorite, and all you did was put the ethyl in place of the hydrogen there. Or hypochloroethane, or probably this is the ethoxychloride. I'm not sure which is the best way to name that, so I'll take either of those 3. Okay. Because that's not one of the functional groups we talked about in this class at all. In fact, it's not mentioned in your book as a functional group anywhere. Okay, any questions about that? So basically there is 1, 2, 3, 4, 5, 6, 7, 8, 9 points possible.
I have a question.
Hmm?
The last one, ethoxychloride, I thought you were supposed to do the short chain first and then the long chain.
But they're different. What I'm naming this as, pretending it's an ether group with the chloro.
Okay.
Or you want to say chloroxy. No, you can't say chloroxy because that means something else.
Okay.
So you can either name it as a hypochlorite, that's this one, or hypochloroethane, or I'm not sure about that last one at all.
Okay.
Okay, but any of those 3 I will accept, and you only need 1 name. If you didn't put any name, put a wrong name, whatever. Okay. So that's 9 possible points for that. Questions? Then, going back here to the other side. This is I-131, half-life, 192.5 hours. What is the activity? Now somebody had a question about the activity, and let me look at this. First of all,
That's good.
oh, look at that. What did they do? I don't know. But it worked. Okay, let's pick that up here. First of all, boy. Oh, I'll move it as I need it. I guess I got it. It's all on. Yes, it's all on. Okay, first of all, from the half-life, you want to get the rate constant. So it's ln2 over this. I did it in reciprocal hours, or I did it in reciprocal seconds, because for activity it says it wants it in atoms per second. This is the total number of atoms. We went through this discussion, this calculation in the lecture just prior to handing out the take-home quiz, which is why I laughed, because I forgot which question I put on the take-home quiz and which one I had on the homework. I think that's what I forgot on the online thing. So I gave you the same problem. So what? You learned how to do it, you learned how to do it. So you calculated the number of atoms because the NDT, and somebody had this question, is it a negative number? And it's like the thing in the, when we were talking about rate constants, one of the books always says rate is always a positive number whether you're dealing with the reactants or the products. Other books want you to put a minus sign showing that something's decreasing or increasing. So I wasn't too worried whether you put a minus sign here or not. But this is the equation I gave you, and somebody said the book gave you a plus. So I'll take either answer without the sign, because you know it has to be what type of number?
A positive number.
No, it's always decreasing.
Oh.
So it's decreasing by a positive amount, I guess you could say, or you just put the negative number and that's the change. Okay, so that's why I said I'm not too worried about the sign, because there are discrepancies between books. But the number is what I really wanted to see, and that's the rate of disintegration per second. Any questions about that? And by the way, I rounded this off, mostly because I ran out of space in the paper. Okay?
Dr. Dan,
Yes?
I thought you were supposed to take the half-life of it.
I did that here to get the rate constant.
But didn't we have a problem once where you did it on the board where you took the sample and you divided it by 2 before you figured out the n?
No.
No?
That was the one where I said you have 20% or 15% or something of the original amount. I think that might be the one I was talking about. In other words, the second part of this problem says decrease to 15% of its original value, so n is 0.15, n 0. What I did say is if I said by or decrease 2, it was 2 different ways of solving it. Here it was let me turn it over so you can read the problem. It decreased to 15, oops, yeah, there it is, to 15% of its original value, in which case I said you would use n is equal to 0.15. If I said by 15%, then I said you'd do what? Maybe that's the part you were thinking of. I probably didn't use these numbers. I forgot what numbers I used. I guess I said 5%, whatever it was. Okay. So that was the difference between by and 2. You know, if you decrease it by a certain amount, there's subtract from 100 to get how much is left. But for the half, I know what you were thinking of when I did the derivation of the half-life. I said we had this equation. In other words, that was the integrated rate equation that we talked about. And now I said when we talk about half-life, and 0, right? So we substitute that in. And this is the equation where when we get rid of the minus sign, it's ln 1/2, which is a negative number, but I would say you take the reciprocal and say ln 2, and it's plus. Maybe that's the part you were thinking. And all I did was, it says ln 1/2 is equal to minus. The same question again, when do you put the minus signs in? When you're dealing with this type of equation, you have to leave the minus sign in because that's what comes out of the integration problem. But notice this is not a fraction, which will give you a negative number as the ln, but if you want to just be fancy about it, all you do is take the reciprocal and it becomes 2, and this goes from a positive, negative to a positive. Those are the little games you play in algebra class. The other person I made fun about that was who? Anderson and Hasselbalch, because they changed the sign with the argument of the law. Okay, so I think that's what you were thinking of where I did the half. And I was just deriving the equation that the book gives you for relating half-life rate constant. Okay, take care of that. Then the other question was, how many hours would it take for the activity? That's why for this one, well, let me go back to the other side now. For this one up here, it wanted the units in atoms per second, so that's why I needed the rate constant in seconds. You could have converted this to seconds. It's just you have to do the reciprocal of the time conversion. So I just figured it's easier to convert the time to seconds than to recalculate the rate constant. So you use this one in reciprocal seconds, and so and this is atoms. So it comes out atoms per second. But the other one said how many hours, so that's why I needed this other rate constant. And then you had ln 0.15 n0 over n0. Notice this will be a negative number when you do it. I wrote it here. You didn't have to show me this. If you said this and wrote the answer, I figured you knew all about the minus signs and kept it straight. So here's the reason for keeping in the minus sign. If you're having a fraction always here, if you're doing the ratio of n to n0, what equation was I using? I was using this equation right here. And so I calculated how long it took for it to get to 15% of the original value, and it was 526.8 hours. Okay? Questions? All set with that? Moving on. Here's the radioactive decay by beta. Oh, I didn't finish the problem out. Oh, that's because I didn't have my periodic table with me when I was doing this. Okay, well, let's finish it out here. Otherwise, I was just sitting. I don't know where I was sitting when I solved this. But basically, you look at AT up here, and it says 85. You need this number because the missing nuclide is 86, minus 1, 85. Up here it's 204, that was the easy part. And now you have to find element number 86 up here, and it's radon. And then here, the same thing. I still didn't have my periodic table. Phosphorus I could have remembered, but I just like to make sure I remembered right. 15, because I don't remember, so I'd look up there and say 83. Okay, so this side is 98. And so it's 97 over here, plus 1 makes 98. And then I look for element 97, and it says berkelium decay. Now that I worked that out, I can write it down. Okay, and then the last one, I gave you a molecule and asked you to write in the first column the types of isomerisms, or the types of names we applied to them. And I did them in the reverse order, the way we found, the way I introduced them, because I saved optical for last. Your book talks about functional first. Doesn't really matter which way. So these are the 5 different types. And the easiest one to deal with is geometric, because what do you need for a geometric isomer? That's the cis-trans isomer. You need a double bond. And the molecule I gave you didn't have a double bond. So therefore, there was no geometric. If you try to make a skeletal out of that, where is it? Way up there. If you move this carbon over here, you can't do it, because it'll have too many bonds. If you move it here, it's exactly what you had before. If you move it over here, it's still the same molecule. And I said the test is, if you end up with the same name, it's the same molecule. So the name of that compound, I think I wrote it up there, you just can't see it. I can see it. 3-bromobutanone, because it's a ketone. Get rid of this one. So this makes it a ketone. And I accepted 2-butanone, but what's the only place you can have a ketone for a 4-carbon chain? On the number 2 carbon. So if you move this methyl group over here, you have this thing. And you put another H there, which is right. It's a 1-bromo, but it's still butanone, so you didn't make a change in the skeleton. It's still a 4-carbon chain for the longest carbon chain. So there's no skeletal isomer possible, unless you want to change this functional group, but I said I just wanted isomers of that particular molecule. Okay.
That doesn't make sense to me. Like,
What?
how come an isomer you can't change?
I said for skeletal isomers, the way you recognize it is that this part of the name changes. The longest carbon chain goes from a but to a prop or something. In the example I used, this is butane.
So were you trying to say find an isomer of just specifically that one and
Yes.
not any other? Like,
It says that. Isomer, all structures should be isomers of.
well, I know, but I could
That thing.
find a skeletal.
There is
that
none.
That was also like.
And it says if there's none, right? None.
But I'm saying that it was skeletal and like geometric or something like that. Like it was more than one type of isomer.
Well, what you had to do was if you changed it to an aldehyde, then you can make a skeletal isomer. But that's not the molecule I asked you to work with.
That's what doesn't make sense to me at all.
It's what I'm saying is, this is a ketone. Everything should be isomers of that ketone. This is a functional isomer because you changed the ketone to an aldehyde. If you change it to an aldehyde and move the carbon over to make it propanal, you've done 2 changes.
So it's
I
no,
see.
so you could only do one change?
Right, that's the only change I want.
I don't
That's
think
why I said
any of us-
You can't write
That's-
one, write none.
Yeah, that's,
Like, cause I thought I asked you on the other day if we can do more than one change, and then as long as it shows a skeletal change.
because I was able to do a skeletal change by
Well-
changing the end of it.
Yeah, I know, if you change it to an aldehyde and put it here,
Then it's-
Well,
and it's a, but that's not an isomer of that, it's an isomer of another aldehyde.
So,
So that's,
I thought isomer just meant the same amount of C, the same amount of.
but I told you I wanted particular types of isomers based on this structure.
We all
You
got
could-
that wrong.
You can make all sorts of molecules out of it.
No, that's what the problem is.
One of the quiz problems I said, and then I wrote that, but I didn't give you that quiz this year, but I did something like this. C4H34 7 OBR. And I said, draw pairs of structures illustrating each type of isomerism. That was the question I asked on one of the quizzes. If you draw pairs, now you can make up any structure for that, that's correct, and draw another one that is an isomer of it.
Okay.
We
Wait,
missed
can you say
that.
one more time?
In other words, this was not the question I gave on this quiz, but lots of people have lots of my old quizzes around. I know there are a lot of them out there. On one of my older quizzes, I gave you that and I said, draw pairs of structures illustrating different types of isomerism. Now you can draw this one, and you can draw the skeletal isomer for this to answer this question, wherever it is. This one here. But that's not the question I asked you this semester. It was the same molecule, I think, because I work out a certain number of things, and I get tired of working them out, so I work this one out.
Where's the English that we were supposed to know that?
What?
Where's the English part that we were supposed to know
Right
that?
here. Let me pull it down. It says what? For each type of structural isomer, column 1, name, and by the way, this numbering went off, so I redid this, but I left each number here, 5, 6, and 7, or 1, 2, and 3, this is the way it's supposed to go. So column 1 was the different 5 types that I talked about. Then 2, it says structural former isomer. You cannot draw a structural for any one of the types, write none. And I said, I want isomers of, and I gave you the molecule.
But if you say pairs of, that means it's
That
still.
was a different question.
But I don't understand how that makes it different. Pairs of isomers
Because
versus
for
isomers?
this, you can take the one that people wanted to do right here. I forget what they wanted to do, but I'll just
Make it a 3.
CH3, CH2, what else?
Put it around it.
CHBr, or you can put the bromine anywhere. CHO.
That's still
Then
the
what you
same.
can do is,
That's still the
here's
same
another
skeletal
pair.
structure though.
CH3, C, C. Okay, now this is butanal, this is propanal. Okay, and that illustrates skeletal isomerism.
Alright, so it's specifically because it is a ketone that we cannot do this.
Right, I gave you a ketone to work with, and I wanted you to draw structures that were isomers of the ketone.
Got it.
Or, if you want a functional, then it can't be a ketone, then you
And when
go
you
to
change
the
it to an aldehyde.
Right.
Okay.
So that's, in other words, I asked different questions using essentially the same molecules. I don't want to give you 20 carbons or 10 carbons, because then you could write 3,000 isomers or 3 million or whatever it was. In other words, the more carbons you have, the more isomers you can draw.
I think we just misunderstood what you were asking. We just decided to make all kinds of.
Yeah, maybe if it said specifically of the ketone, maybe we would have
No,
been a little
that
bit
is the
more.
ketone.
I know.
It says of,
Where?
So then,
and there's the molecule right after it. I
Yeah,
added the
you said
asterisk to show you that it had a
No, there is no
asymmetric
pairs.
carbon. Notice if I would have put the bromo out here,
Yeah,
You
I don't
couldn't
see
have
how
done-
that's
Sorry, I can't
fair.
hear you.
I don't see how that-
What?
I can't hear you.
I'm talking, somebody can't hear me. I said if I would have put the bromo out here instead of here, then you would have said for optical, none. Because there was no optical isomer with the bromo out here, because it's not asymmetric anymore. Yes?
so with that, the way that question is worded, you can't have more than one isomer change
Right,
in the
I
same.
didn't wanna have 3,000 things to look at.
But I guess that's what I was confused, because when I asked, like, if it could change more than one thing, you said it could as long as it's set with.
Well, I was answering the question for the other one, I wasn't answering the question for the quiz, because once I give out the quiz, I'm not gonna answer questions about the quiz.
Oh, if I
Oh.
said that, that would have been better.
Oh,
That's your
it's a general question, because I have other quizzes, and maybe you saw some of the other quizzes. People do see some of my other quizzes, I'm sure you all had other quizzes to study from, don't you? There should be a lot of them out there. Okay, so, for another quiz, that was the correct answer, because on the quiz where I asked you to just draw pairs of structures, then you could make other changes. Or the one question where I asked, one time, I don't think I had that many carbons, but I said draw all possible isomers. then you can start shifting functional groups around and everything else. I didn't want you to sort it by categories or anything, I just wanted all possible isomers that you could make up. Which is another reason I don't put too many carbons in there, because I have to read all these things and then decide whether you did it correctly, yes.
Also for quiz 13 online, the first question that you ask, this is the